Hi everyone, and welcome to the next video in this section. Now that we had talked about relations, now we need to talk about the definition of the function. And the formal definition of the function is this. A function is a relation in which every element of the domain corresponds to exactly one element of the domain. So, what does that exactly mean? So, let's look at a non-example first. A non-example was exactly what we had done before. So let's set X, again, be people Jack, Jill, Paul, and Mary from our previous example. And we're gonna, let's write that X a little more nicely, and then let's let Y be a set of classes again. So let's say math, science, music, and history. So typically an association between people and classes is not going to be a function because a person can take more than one class. So for example, Jack could take music and history this semester. This semester Jill may take science and music. Paul may just take math, and Mary may take some science and history this semester. So notice that each one of these people have taken at least one class, and many of them have taken more than one. So notice that each one of the elements in the domain is used twice. So this is just a relation. A good example of a function is GPA. So let's look at an example using our same people. So we'll have Jack, Jill, Paul, and Mary. And this time we're going to associate their GPA to them. So let's say this semester they got a 3.8, a 3.7, a 3.2, and a 2.9. So they didn't do quite as well last time. So this is my set X of people, my set Y of GPA. Now, each person has exactly one GPA. A person cannot have more than two. So Jack maybe has 3.7. Jill maybe has 3.8. Paul may also get 3.8. And Mary maybe not did so well this semester and got a 2.9. And notice here, kind of the big idea here is that each person has exactly one value associated with them. So Jack has one GPA, Jill has one GPA, Paul has one GPA, and Mary has one GPA. It does not matter that Jill and Paul have the same GPA. So it doesn't matter if there's two arrows right here in the definition of the function. So the fact that I have two arrows right here doesn't mean anything. This is still a function because all it matters is over here there's only one arrow for each person. So this, let me return to my normal color, is a function. Yay, we've seen a function. So now we want to turn this into ordered pairs. So let's look at this previous example as ordered pairs. So in this example, again, we're going to use a little curly bracket since we're going to do a list of ordered pairs. So in our first ordered pair, well, Jack had a 3.7. So Jack is the first element, so that comes from the domain. Let's write that a little better, maybe. There we go. And he got a 3.7. See, Jill this semester got a 3.8. Paul also got a 3.8. So let's put the round bracket there. And let's make this a little smaller so we can see everything. And then Mary got a 2.9. So this is the same relation. So this is also a function. And notice what the defining characteristic of a function when it's written as ordered pairs. We have notice that we have repetition allowed, and I miswrote one of these, so let's fix that. Paul had a 3.8, so that was a mistake, so that's been fixed. And so notice that we have repetition in the second coordinate, but notice that all the first coordinates do not have repetition. Jack, Jill, Paul, and Mary are all separate objects. So notice that when we look at function notation in terms of ordered pairs, an equivalent definition is as follows. A set of ordered pairs is a function if all the first coordinates are distinct. And are distinct. Well, sorry for the little audio gap there. So when we look at sets of numbers, really all we have to do to determine if something is a function, you just look at all the first coordinates. If there's any repetition at all, there is then it's not a function, it is just a relation. So example, the set 1, 0, 2, 4, and -3, 8 is a function, since the domain, which is just 1, 2, and -3, contains no repetitions in the list. Another example, if we have the set 0, 0, 1, 1, -1, 1, -2, 4, 2, 4. So we recognize these as points on a parabola. And notice that the this is a function too. So that's another good example of a function. I was trying to create not a function, and I was thinking of a different property. So let's just use this as another example of a function, and let's actually come up with a non-example. So this non-example, we better put some repetition in the first coordinate this time. So we'll have, let's try again 0, 0, but this time we'll have 1, 1, and we'll have 1, -1. And then we'll have 2, 4. And that's good enough. And because we have the repetition here and here, this is not a function. Alright, that's the end of this video, so we'll move on to the next one, and I'll see you in a little bit.